Hey everybody, hope you're doing well and hope you guys have been watching your science videos. Yesterday we learned about heat transfer. How does heat move? Um, and we learned that there are three different ways that heat moves, that heat transfers: convection, conduction, and radiation. So today we're going to talk more about that and we're going to take some notes. So make sure you have your science notes out and a paper, pencil or pen so that you guys can jot down what I'm jotting down. So the first heat transfer we're going to discuss is convection. And one little hint about convection that I like to remind everybody is that convection is the only heat transfer with a V in there. Now if you make a V with your arms are raising up. So we can remember that convection is when heat rises. Well, let's talk about the science behind that. Why does heat rise? Let's take my little patch of air here, patch of air A, and here's going to be patch of air B. And they could be liquids as well, because convection occurs in liquids and gases, not solids. So let's take this patch of a gas or a liquid, and let's just make it a regular, we'll make it a gas. Our molecules are spread apart. Now I'm going to take some heat. So maybe it's the sun, maybe it's a hair dryer, any type of heat, and I'm going to add it to this sample. And now these molecules are going to move around even more. And so maybe this molecule is going to move out here, and this molecule is going to move over there. So inside my sample, I have less molecules. So what is going to be heavier, A or B? A is going to be heavier. So A is going to sink, whereas B is going to rise on top. And therefore, adding heat, adding energy is going to make it lighter. And just think about, even just if you were to do the little pyramid, the cheerleader pyramid, you're going to want to have the heavier people at the bottom and the lighter people at top. So the lighter water or the lighter gas or the lighter fluid is going to rise on top of the heavier gas or the heavier fluid. All right, so for convection, go ahead and write this down. It's the transfer of heat. And in this transfer of heat, well, let's say it's in gases and liquids. Where heat rises and cool sinks. Okay. And actually, guys, if something feels cold, it's actually just the absence of heat. It doesn't have much heat. So, for your question today, to make sure that we're watching a video, the answer to the video is going to be what I'm saying right now, or the answer to the question is going to be what I'm talking about right now. A good example of convection. Okay, I used to live in Boone, in the mountains, and that's where I began college. In my second year, I lived in a condo, and we were on the second floor, and some grad students lived below us on the first floor. So let's draw my little condo. All right, so there are some stairs right here. All right, our door, their door. So here's the first floor, and here's the second floor where my friends and I lived. Now during the winter in Boone, it's in the mountains, so it gets a lot colder than it does here. We even see a lot more snow than we see here in Wilmington. So it gets really cold in the winter. So the people that live below us in the winter would put their heat on. Okay, so they would set their heat, and here's the two people that live there. They'd set their heat, and they'd still be a little chilly, because what would happen is all the warm air from their heater would rise, and it would rise up into my apartment. And then we, who lived in my apartment, there's three of us, high as they did, because their heat that they were paying for was rising and going through the floors and coming up into our apartment. So we were kind of getting off with a little bit of a cheaper power bill each month than they were, because their heat was rising into our apartment, their heat that they were paying for. So that's an example of convection, the heat rising. Another example of convection that we talked about yesterday is a pool, okay, or an ocean or a lake. But that top of the water, okay, right up here, is going to be warmer because it is lighter and it rises. The cooler water is going to sink to the bottom. That is another example of convection. Another example of convection is going to be when you have your pot of water and you are boiling your water to put maybe your noodles or your rice or whatever you put in your boiling pot of water, and the water starts to boil. And you know, okay, it's time to put the noodles in. And the reason is because now you know that all the water's hot and your food is going to cook evenly. Well, the reason that happens is because in convection, that warm water is going to rise. And it's going to rise, and then it's going to stay on the burner and keep getting hot, and it is going to keep rising, and it's fighting to get to the top. I'm fighting to get to the top, on top of this water. I need to get on top. I'm rising. And that's what causes that energy, that boiling right there. Now, once again, convection only occurs in liquids and gases. However, it can also occur in sand. And sand is actually a solid. And there is a story that I always tell about Miss McIntyre. Miss McIntyre down the hall, who is the AIG teacher here. She used to be a 5th grade teacher, but now she's the AIG teacher. And she, one time, was at the beach, and they had a fire out on the beach. And they were putting, she had her shoes off, and she was pushing the sand over the fire where it was hot, and she had her feet on there. Well, she had her feet resting, but convection occurred in the sand. So the hot fire that she had covered with her foot, or that she covered with sand, was cool. But eventually convection occurred, and that heat rose through the sand, and it burned her foot pretty bad. So she even had to go get some bandages. So that is an example of convection occurring in solids, but it generally, besides sand, it only occurs in liquids and gases. Our next heat transfer that we're going to talk about is conduction. And when I say conduction, I like to say it like that because I can then make myself remember that conduction sounds like touch. Conduction, conduction. Well, I'm stretching it a little bit. But it will help us remember that conduction is heat transferred by direct touch. So, let me make sure I get the definition I'm looking for. Okay, so conduction occurs in, the best conductor is metal. And what I wanted to show you, and I'm just realizing in my video that you won't be able to see, but right here, okay, you guys know that there is a metal board where we keep our dry erase markers, okay? So, let me fix this. I'm going to touch that metal, and if you guys can find any metal right now, try to do it as well. So maybe you're sitting at a chair that has a metal legs, and you guys can touch that. If you were in the classroom right now, I would have you touch your chair legs, or I would have you touch your desk legs, because those are metal. And when you touch that, it feels cooler, doesn't it? Do you think that the metal in the room is actually cooler than the rest of everything else in the room? No, it's not. The reason why it feels cooler is because metal is the best conductor. And when I touch that metal, it's not cooler than anything else in the room. I can touch that metal and I can touch this highlighter, and they're the same temperature. but the highlighter doesn't feel cold when I touch it, just this metal does. And the reason is because metal is a good conductor of heat. It is taking the heat from my body, which is making it feel cooler. So that's pretty interesting. And once again, I am touching that. So, conduction is the transfer of heat from atom to atom, or the bigger molecule to molecule, where the energy is transferring through direct touch. Through direct touch. And remember, that kind of sounds like the dush in conduction. So it's a transfer of energy through touch. And let's also add to that, metal is the best conductor. Okay. And so some examples of conduction. Have you guys ever had a sore muscle, and so you put a heating pad on your muscle? Sometimes that happens to me. Maybe I'll pull something, and so I put a heating pad on it, and it kind of makes it feel better. Well, the heating pad on, for example, your leg is a great example of conduction. The heat is transferring, that energy is transferring from the heating pad to your leg. Another example of conduction, like I said yesterday, is when, remember I said when I was about your age, I leaned on the oven and the stovetop was on, and it burned my hand. My hand was directly touching that and that stovetop, and it burnt my hand. So anytime that you touch something that is warmer and that heat transfers to you, that is conduction. Or anytime anything else touches something and gets warmer, that would and gets the heat from that object, that is conduction. So let me just look at a couple examples. Oops. I just switched out of that. All right, yesterday we talked about when you are eating maybe soup and you put your soup into the bowl, your spoon gets hot. So then, because it is directly touching the hot soup, and then you put it to your mouth and your mouth gets hot because now your mouth is directly touching the spoon and the hot soup. So that's another example of conduction. And then we have radiation. And radiation is heat transfer through electromagnetic waves. Can you see those electromagnetic waves? I can't. So an example of radiation is, you know, if you guys were here on a normal day and we're going out to recess, I might say, all right guys, you feel that? You feel that sun? You feel that heat? And you guys would all, yes, it's hot, let's go back inside. Can we have indoor recess? That heat is transferring to you from the sun through electromagnetic waves. It's being carried down to earth through those electromagnetic waves. Another example is anytime you know you're feeling heat and you're not touching the heat source, because of course that would be conduction, and you're not over the heat source because heat rising would be convection, but you're next to it and you feel it. So if I were at a campfire, that's my campfire, and I'm warming up next to the fire, that heat is transferring to me through electromagnetic waves. That I can't see it, but I can feel it. All right, and we are going to continue talking about heat transfer tomorrow. So don't forget to go in and answer your question. I told you where the answer was about in the middle of the lesson. I think it was maybe more toward the beginning. And I hope you guys all have a great day. I hope you are getting through your iReady testing this week. I know we're starting today. And see you later. Bye.